Hello, Accelerated Math 6-7 students. We are now beginning our Lesson 15 video. And as you notice in the table of contents, I have run out of room. So I get to turn the page. And just a quick reminder that when you have to turn the page in your table of contents, you need to make sure that it says Table of Contents up at the top. And then remember, you have to write the title of the lesson and what page it starts on. So the lesson that we're doing today is called Getting the Job Done, Working with Speed, Work, and Measurement Units. And this can be found on page 35 in my comp book. So I'm going to turn there now. So page 35 is right here. And it is called Getting the Job Done, Speed, Work, and Measurement Units. Our goal today, we are going to use rates to convert in different measurement units, different measurement units. Sorry, let me read that again. Today we are going to use rates to convert in different measurement units. The question that I want you to be thinking about is, what must you include in all of your problems when converting units of measure? So we will make sure that we answer that by the end of the lesson. Conversion practice. So I'm going on the fact that I hope that all of you either know about conversions or by this quick little memory jog, you'll be able to remember what conversions are. And so the first one that I want to practice is how many feet are in 48 inches. So the two things that you're comparing in this example right here is inches to feet. Okay, so that's what we're converting. We're trying to convert inches per feet. And so far, the question says how many feet are in 48 inches. So we're comparing inches per feet. And what you need to do is you need to write what you know. Okay, so we have 48 inches per how many feet or foot. Okay, and that's what we're looking for. So basically what you have to do is you have to set up your rate, which we have set that up, okay? It is inches per feet. And then what you're trying to figure out is how many feet are 48 inches. So we can do that by using a conversion chart. We know that 1 foot equals 12 inches. We know that. So what we're going to do is we're going to take our 48 inches and we're going to multiply it by 1 foot per 12 inches. And it has to be written in that way because we're trying to get rid of our inches and turn it into feet. And the only way we can do that is by dividing them out. So if I take 48 inches times 1 foot per 12 inches, my inches can simplify to 1, so they're gone. Okay, now I'm left with feet or foot. Feet is what I would like it to say. And then I just multiply. So what is 48 times, remember this is simplified to 1, so it's no longer there, 48 times 1 foot? Well, 48 times 1 is 48. 12 times nothing, because I didn't multiply it by anything, is 12. So now I have 48 divided by 12. And then that just becomes your math problem. 48 divided by 12 equals 4. And what is the unit of measure that I'm left with? Feet. So now I can answer the question. How many feet are in 48 inches? There are 4 feet. Okay. I know that English-wise it sounds a little bit weird and discombobulated, but mathematically this is absolutely what you have to do. You have to find what they have in common that you can simplify to 1, so that unit of measure goes away and you're left with the unit of measure that you're looking for, and then you do the math to solve it. Okay? So let's try another one. If I have right here how many grams are in 6 kilograms, so basically the way I set up my rate is I do the amount I'm given per the one I want to know. So I have kilograms per grams, and I want to know 6 kilograms is how many grams? So I put a question mark, okay? Well, I know that it takes 1,000 grams to make 1 kilogram. So 1,000 grams per 1 kilogram. And the reason I write it this way is because I need to do kilograms divided by kilograms to simplify it to 1, because kilograms divided by kilograms is 1. 1 times 1 is 1. 1 times 6 is 6. So that's how I'm okay there. And then I multiply straight across. So 6 times 1,000 gives me 6,000. Kilograms is gone, so what is the unit of measure? The unit of measure is grams. So how many grams are in 6 kilograms? 6,000 grams are in 6 kilograms. Okay? Sounding okay? I think that once you practice it and write it out and try it, it will get easier and easier. But it does take time to practice it out so that you can do it. All right, so now I'm going to have you try one by yourself. Okay? How many cups are in 5 quarts? So I'm going to talk you through it, but I want you to do it. How many cups are in 5 quarts? So remember what I said, the amount that you're given compared to the amount you want to know. So we have quarts per cups. We know that there are 5 quarts in how many cups. So your job is to figure out the conversion. Okay, so the question here is, how many cups are in 1 quart, right? We need to find for 1 quart. Well, okay, let's think about it. We know that there are 2 cups in 1 pint, right? And we know that there are 2 pints in 1 quart, right? So now we have to figure out how many cups are in quarts, okay? Well, that's easy. We know that there are, if we simplify the pints out to 1, 2 times 2 is 4 cups per 1 quart. So that's what we know right here. So cups to quarts. So now that's what we would put right here. So we would say that we have 5 quarts equals how many cups, and we know that we have 4 cups in 1 quart. So we want to simplify the cups because we're looking, we need to simplify the quarts. It's hard to know which one you're doing. We're going to simplify the quarts, leave the cups because that's what we want to know. All right, so these simplify to 1, so now they're gone. 1 times 5 is 5. 5 times 4 equals 20, what? 20 cups. So now we know that there are 20 cups in 5 quarts. Does everybody see that? Okay? I know, it gets a little tricky. See, it even tricked me, and I've been doing it for years. Okay? So let's try another one. If we know that there are 20 cups in 5 quarts, we now want to know how many quarts make up 10 cups. So again, go with what you're told or what you know, and it's this time we're flip-flopping it. We're doing cups per quart this time because we're given the cups. So we have 10 cups equals how many quarts this time? Okay, and we know that there are, what did we learn on this? We learned that there are 4 cups for every quart, so we know 1 quart equals 4 cups, right? And we're looking for quarts, so we're going to simplify the cups, right? So simplify the cups to 1, and we have 10 times 1 is 10, times 1 is 10, so we have 10 divided by nothing times 4, so that's 4, and then we have 10/4 quarts. So the question is, how many quarts make up 10 cups? Well, we could say that, sorry, I'm coughing, sorry. 10 cups equals 2 1/2 quarts. Sorry for coughing. Okay? So hopefully this is making sense to you. Like I said, it just takes practice, and you have to set up your little model in the correct way in order to find the correct unit of measure. All right, I'm going to turn the page. I'm so sorry for coughing. You have one more task. It's one problem, but there's actually three different things that I need you to find. So it says if Mason can run 9 and 43/100ths of a yard in 1 second, holy moly, that's fast. How many yards can he run in 1 minute? So what you have to do is you're trying to find yards per minute. Sorry. But what we have is we have 9 and 43/100ths yards in 1 second. So we actually have to convert from seconds into minutes. So we have 9 and 43 yards per 1 second. Let me put yards on there so you don't forget what it is, and that's what you have to remember to put on everything is your labels. And I forgot, so let me put yards on there. 9 and 43/100ths of a yard in 1 second. We know that there are 60 seconds in 1 minute. So now if you remember what we're doing, we need to simplify the seconds off into 1 and then multiply straight across, and that tells you how many he can go in 1 minute. Okay? Then you're going to take that information that you found up here, and you're going to find out how long it takes or how many yards he can run in 1 hour. So we're doing yards per hour. 565 and 8/10 yards in 1 minute. So then what would your conversion rate be on this one? I'll give you a hint. Your units of measure that you're trying to simplify to 1 always has to be across from each other. And when I say across, I mean diagonally across. So what is the unit of measure that has to go right here? If you said minutes, you are correct. So we have something minutes per something hour. Okay, does that make sense? And when you're done, you're going to simplify these minutes to minutes, and then it will end up with how many yards per hour. Okay, so that's another clue to help you be successful with this one. And then the last one you have to do is you have to take that answer that you got, and we're now looking for how many miles can Mason run in 1 hour. So we're converting yards to miles this time. And so we know 33,948 yards in 1 hour. Then you have to know the conversion of the number of yards in 1 mile, and then it will tell you how many miles he can run in 1 hour. Okay? It's kind of fun. The most important thing to do is put your labels on there. If you don't have your labels in the right spot, then you can't simplify to 1, and then you're going to get lost. So let's go back to our question for this lesson. Our goal was today we are going to use rates to convert in different units of measure, measurement units. That's what we did. What must you include in all of your problems when converting units of measure? The answer to that is you have to put your labels. You have to put your units of measure on there. Every single problem, you have to put your units of measure. Have to put your units of measure. Every single problem. The answer, what must you include in all of your problems when converting units of measure? You have to put your labels of your units of measure. Okay? Have fun with those last 3 problems. I'm very interested to see what you can come up with, and I will see you all tomorrow. See you later.